Hello, my name is Andrew Lombardo. I am with KX Technologies, and I am here to talk about waterborne disease and treating carbon for purification. This is a powerful quote. Poor sanitation and lack of safe drinking water have been estimated to take a greater human toll than war, terrorism, and weapons of mass destruction combined. This really gives you an idea on just how big of a problem this really is. The statistics on waterborne disease are shocking, and one of the most awful things about the deaths associated with waterborne disease is that such a huge percentage of the deaths are from children. 4,000 children worldwide die each day due to waterborne disease. Approximately 3 adults and 3 children die every minute. And beyond just the terminal cases, the WHO estimates that there are approximately 4 billion cases of diarrhea each year. We may think that this is only a problem in the developing world, but in the US, waterborne outbreaks are reported routinely. This was some data that we collected trying to track boil water alerts across the United States. And this was only the data that we found. There is no central data collection on boil water alerts. The Water Quality Association, which is a standards and third-party testing organization in the United States, suggests a final barrier approach. They envision water being treated at a central location for an area and then treated again close to the point of consumption. They estimate approximately only 1% of the water going into a home is actually used for consumption. So let's talk about what waterborne disease is. The truth is, there are many different waterborne diseases, but they're all caused by either bacteria, virus, or protozoa in the water. And you might ask, well, if we know what the problems are, why is it so hard to fix this? And there's a lot of reasons, but size plays a big part of it. Bacteria are typically 1 to 3 microns. Viruses are typically less than 0.05 microns, and cysts are typically between 3 and 10 microns. To put this into perspective, if you were to take a typical filter that you can buy at Lowe's or Home Depot, which has about an outside diameter of 2.5 inches and length of about 10 inches, if you were to take that filter and scale it up to be the size of the Empire State Building, at this size, a cyst would be about the size of a child's rubber ball. Bacteria would be about the size of a pencil eraser, and virus would be smaller than the tip of the pencil. These are very, very small. Another reason why waterborne disease is a difficult problem to fix is the performance requirements. In 1986, the US EPA established a basic standard to evaluate filtration technologies. They set the standard as 6 log reduction for bacteria, 4 log reduction for virus, and 3 log reduction for cyst. This standard has been the basis for most of the evaluation protocols throughout the world. Again, to put this into perspective, a typical challenge solution for testing a purification technology will have greater than 1 million bacteria per 100 mils of challenge water. 100 milliliters is approximately about half a cup of water. This is equivalent to filtering the entire population of Manhattan out of every 100 mils of water. And by this protocol, if more than one person was to get through, the system would be considered a failure. For virus, a typical challenge water will have more than 10,000 viruses per mil of challenge solution. This is equivalent to about the undergraduate student population at University of Pittsburgh, which is not too far from here, in every drop of water. And by this protocol, if more than one student were to get through, the system would be considered a failure. Some certification and governmental organizations are recognizing that reducing levels lower than that dictated by the US EPA guidelines can still make a difference in the overall impact of waterborne disease in society. The WHO released a tiered approach to evaluating filtration systems, splitting them into interim, protective, and highly protective categories. This is the theory behind the change in policy from the WHO. DALY stands for Disability Adjusted Life Year and is a measurement of the overall disease burden. Mexico and Brazil also have their own standards which allow less stringent evaluations for filtration products. Basically, they're recognizing that less stringent requirements can still have a profound effect on the total disease burden of a country. So how can we address this need? KX Technologies has been dedicated to developing products that address this global need for over 11 years. We have been developing technologies and products that are targeted towards removing bacteria, virus, and protozoa from water. And one of the most elegant technologies we've come up with is a method to treat carbon that can be used in a variety of systems to target this goal. It is important to note here the difference between disinfection and filtration. There are many technologies out there that rely on disinfection and dose in chemicals such as bromine or chlorine into the water in order to kill the microorganisms, but you end up drinking the dead organisms. These technologies have their use, but we've been targeting filtration technologies, which give a greater level of protection because they actually physically remove these organisms from the water. So how do we do it? We start off treating the carbon with a cationic polymer. We then add a metal halide such as silver bromide to the surface of the cationic polymer. When in water, this complex extends out from the carbon surface and can electrostatically remove pathogens. We can take this carbon powder and produce carbon blocks or integrated papers to produce finished filters. Typically, we try to target filter pore sizes that will remove the bacteria and protozoa by size exclusion. The virus is then removed by electrostatic attraction. This picture gives a quick comparison to other technologies that are available. Those particles in the water, such as virus, that are between 0.01 micron and approximately 0.1 micron, can be removed electrostatically. Those larger than that will typically be removed by size exclusion. A few examples of products. This is a product that KX Technology produces that is sold in the United States via retail channels. This carbon block style filter is the first and only product to be certified in all 50 states as a microbiological purifier. These show some typical third-party test results. You can see that the influence are an order of magnitude higher than the minimum standards, and the filter showed no bacteria or virus in the effluent throughout the entire life of testing. Another style of product utilizing the treated carbon that we've been developing is an integrated paper, targeted more towards third world areas and areas that don't have high water pressure. This paper utilizes very small particles of carbon and will flow under very low pressure or even gravity conditions. We have several products being sold into Mexico and Brazil for low pressure but plumbed systems. This product can also be targeted specifically for gravity applications. We are launching a gravity product this year into India, which has been tested at UL Labs to a proprietary protocol based off of the EPA guide protocol, which will remove 6 log bacteria, 4 logs of virus, and 3.5 logs of cyst. This is the system that's been designed. The filter itself is about 3 inches in diameter, and it's about 4 inches tall. It's a little bit bigger than a softball. It is also worth noting here that another problem with delivering filtration technologies to the developing world is that most of the areas that desperately need these technologies don't have a lot of water pressure, if any at all. I described the size of the contaminants as well as the challenge loads, but to give you an idea on the challenge of pressure, if you were to take a number 2 pencil and rest it with the eraser in your palm of your hand is feeling more pressure than this filter sees to remove all those small contaminants at those high levels. And these are some test results that we got from UL. This shows that the bacteria reduction across the life of the filter was greater than 6 log, most of the time greater than 7. And the filter life was approximately tested to 1500 liters. This is similar data for virus removal, showed greater than 4 log reduction of virus throughout the entire life of the test. And lastly, for cyst reduction, showing greater than 3.5 log reduction throughout the entire life. This is some internal test data comparing turbidity against commercially available products in India. Approximately 70 NTU dirty water was put through the filter and the turbidity of the effluent was measured. The purple and blue lines are both disinfection technology. Basically allowed the dirt to flow right through, leaving water still brown and dirty. Our integrated paper technology showed less than 1 NTU in the effluent throughout the entire life of the test. And this shows the total volume of water that a single filter can produce. One small filter, about the size of a softball, can produce 1,500 liters, which is about 77 5-gallon buckets of clean, safe drinking water. So in conclusion, chemical treatment of carbon is an excellent way to enhance filtration technologies, and it can be applied in many different types of filters. It has a great potential to make the problem of waterborne disease a thing of the past. If you have any questions, feel free to contact me. Thank you.